Picture a dim reddish star, TRAPPIST-1, just 40 light-years away, with 7 Earth-sized planets orbiting close by. This real system, discovered in 2017, electrified astronomers. So many rocky worlds all in one place. Each planet is about the size of Earth, raising the question, could any of them be habitable? Among them, TRAPPIST-1e stands out. It orbits in the Goldilocks zone, where temperatures might allow liquid water. That makes it a prime candidate in our search for life beyond Earth. TRAPPIST-1 is an ultra-cool red dwarf, the most common star type in our galaxy. These stars can be stable for billions of years, but they're also prone to violent flares, especially when young. Such flares could strip away a planet's atmosphere, threatening its habitability. The big question, can TRAPPIST-1e hold onto its air and water, or is it a barren rock? Studying this system lets us compare multiple Earth-sized worlds around a single star, a rare cosmic laboratory. The answers we find here could reshape our understanding of where life might exist in the universe. That's why telescopes around the world, and above it, are focused on this tiny distant sun. The search for another Earth has never felt closer. How do we study a planet 40 light-years away? We use light, and the James Webb Space Telescope. Webb sees in infrared, letting us peer through cosmic dust and detect faint heat from distant worlds. When TRAPPIST-1e passes in front of its star, some starlight filters through any atmosphere it might have. Different gases absorb specific wavelengths, leaving a chemical fingerprint in the light. Webb's NIRSpec instrument breaks this light into a spectrum, revealing which gases are present. The signals are faint, like spotting a fly's shadow in a searchlight, but Webb's precision makes it possible. By comparing starlight during and outside a transit, scientists hunt for signs of air, water, and more. Each new transit adds data, sharpening our view of these distant worlds. This technique, called transit spectroscopy, is revolutionizing exoplanet science. With every observation, we get closer to answering, are we alone? The universe is finally giving up its secrets, one spectrum at a time. Webb's latest data gives us our clearest look yet at TRAPPIST-1e. Scientists found no thick, hydrogen-rich atmosphere, meaning the planet likely lost its original air to stellar flares. But that opens the door to a secondary atmosphere, like Earth's, formed by volcanic outgassing. Gases such as carbon dioxide or water vapor could create a new protective blanket. The big mystery, is TRAPPIST-1e a dry rock, a water world, or something in between? If it's tidally locked, one side could be a sunlit ocean, the other a frozen night. To keep water liquid, the planet needs a substantial atmosphere to trap heat. Without it, any water would freeze solid. Webb's data isn't conclusive yet, but the search for carbon dioxide and water vapor signatures continues. Each new observation brings us closer to understanding if this world could support life. The possibilities are tantalizing, and the investigation is just beginning. TRAPPIST-1e remains one of the most intriguing exoplanets we've ever found. Why do we care so much about atmospheres and water? Because on Earth, they're essential for life. An atmosphere shields a planet, regulates temperature, and keeps water stable on the surface. Water is the universal solvent. Every living thing we know depends on it. So finding a rocky planet in the habitable zone with water would be a breakthrough. TRAPPIST-1e is part of a bigger story. By comparing it to its siblings like the airless TRAPPIST-1b, we learn how distance from a star shapes a planet's fate. This comparative planetology helps us refine our models of habitability. We're no longer guessing, we're measuring the chemistry of alien worlds from light years away. Each spectral line brings these planets into sharper focus. We're transforming distant dots into real places with geology, weather, and maybe even biology. This is a new era of exploration, one where we can finally ask and begin to answer if life exists elsewhere. The search is no longer science fiction, it's happening now. Webb has opened a new window onto TRAPPIST-1e, but the real journey is just starting. The next step search for heavier gases like carbon dioxide and water vapor, signs of a secondary atmosphere. Scientists also want to know if the planet is volcanically active, which could replenish its air. Understanding the star's flares and the planet's internal structure will help reveal if TRAPPIST-1e is truly habitable. Each discovery teaches us more about our place in the cosmos. Our solar system is just one of billions. Earth may not be unique. The quest to explore, to question, and to wonder is what drives us. And with Webb, our voyage into the unknown has only just begun.